The four main features that you are going to be looking at for any cosine or sine function starts off with the amplitude. Remember, the amplitude is what tells you how high up and how low down it either stretches or compresses. And you find it by looking at this leading coefficient here. Even if it's a negative coefficient, the amplitude will always be the absolute value of that number. So in this case, our amplitude would be 2. We also want to know what the period of the sine or cosine function is. A normal period in degrees would be 360 degrees because it takes 360 degrees for sine or cosine to go through one full cycle of its curve. To figure out what the new period would be in a transformed function like this, if we're talking about it in terms of degrees, then you take 360 total degrees and divide by whatever this coefficient is. So in this case, 360 divided by 3 tells us that our new period is 120 degrees, meaning that this cosine function is going to start and finish its curve within a 120 degree range. Next, we look at the phase shift, which tells us how much the function got shifted either to the left or right horizontally. You see a phase shift by whatever is inside of parentheses. Now, if there's no parentheses in the function, then that just means it did not get shifted left or right. Since this one does have parentheses, to figure out how much it got shifted, you take what's in that parentheses, so 3 times theta plus 90, you set it equal to 0, and you solve for theta. So in this case, I'd have to subtract 90 from both sides, and then I'd also have to divide by 3. And that gives me a theta equal to negative 30 degrees. What that means is that the cosine curve that we're looking at here got shifted left, because it's negative, left 30 degrees. That's going to be important when we sketch our graph. The last characteristic that we look at is the vertical shift. The vertical shift is seen by the value that's either added or subtracted at the end. And again, if there isn't a value added or subtracted, that just means there was no vertical shift. In this case, that negative 1 right there tells us that we got shifted down 1 unit. This is also going to be really important when we sketch our graph, because rather than everything revolving around the x-axis, this cosine function is going to be revolving around a horizontal line that's at a negative 1. So putting this onto the graph, don't forget to keep in mind what the parent function for cosine in this case looks like. The parent function for cosine starts at a positive 1, and then it comes down to 0, continues down to negative 1, comes back up to 0, and finishes back up where it started at positive 1. And if I fill in the curve, this is the general shape of the parent function for cosine. So keep this in mind, but to start, you're going to take the vertical shift and draw a dotted line, dotted horizontal line, wherever that value is. So rather than it being here, we're going to go down 1, and that's where we're going to put our dotted line. Because again, this is now where everything in the function is going to revolve around. Like that's like our 0 line, that's our x-axis now. After you've plotted that dotted line, then go to your phase shift, because this value tells you where you're going to start. Normally we'd start at 0, but in this case we need to go left 30 degrees. So this would be negative 30. Now usually, like I said, cosine starts above the x-axis 1, but in this case we're going to not start above our axis 1, we're going to actually start above our axis 2, because we got stretched by 2. So left at negative 30, from our down 1 horizontal line, we're going to need to stretch up 2, so that's up 1, up 2, that's our new starting point. Now I also want to go ahead and figure out where this is going to end. To find your end point, take whatever the phase shift was and add the period to it. So in this case, our phase shift was negative 30, our period is 120. That tells us that we're going to end at 90 degrees on the graph. So if this is 0, and this would be 30, and this would be 60, then this would be 90. And that's where we will end. And then again, go back to the parent function. When cosine ends, it's back where it started. So at 90, we should be up here, just like we were back where we started. From there, you just have to fill in where these 3 key points would go, which you'll notice in the parent function for cosine, halfway between the beginning and the end, we are at our lowest point. So halfway between our beginning and our end, we should be at our lowest, which our lowest would be not just 1 below our horizontal line, but 2 below because of that stretch of 2. So I know I'd be there in the middle. And then in between the first and the middle, and then in between the middle and the last, we're going to be at our 0 line, which again, our 0 line here is at -1. So I put a point there, and I put a point here. And then from there, I just have to fill in my curve. And you don't have to draw more than 1 cycle, but obviously if you wanted to, you know that this should keep going because it is a periodic function. But really what I would be looking for is that 1 full cycle right here. To show you another example, this one's going to be a sine function. So in this case, the parent function that we're going to keep in mind is the one that starts at 0, goes up to 1, comes back to 0, goes down to -1, and comes back to 0 to end. This is the parent function for sine. And so we're going to start by looking at our characteristics. We want to know the amplitude, which in this case, we got another stretch, but this one got stretched by 4. We want to know the period. Normally it takes from 0 to 360 to complete a cycle. In this case, it would be 360 divided by that number right there, which is 2. So we're going to complete 1 full cycle within 180 degrees on this one. For the phase shift, I know there is a phase shift because of what I see in parentheses. To figure out how much it got shifted, I'm going to set what's in the parentheses equal to 0. And I'm going to solve for theta. And so in this case, when I divide by 2, I get that theta, the phase shift, is equal to a -60 degrees. So rather than starting at 0, I'm going to have to start to the left 60 degrees. Left because it was negative. Lastly, I want to look at a vertical shift. Again, I know there's a vertical shift here because there is a number that got added or subtracted at the end. Since it got added, that means I know that this graph got shifted up 3. Now, taking all of this plus what I know about the parent function and sketching a graph, I'm going to start by drawing my dotted line that'll be like my line of symmetry. And that dotted line is not going to be at the x-axis. It's going to be up 3 from the x-axis. So it'd be right around in here. Now I'm also going to figure out my starting point, which remember, normally I'd start at 0, but in this case I need to start left 60 degrees because of that phase shift. Now sine does start at 0, and so when I'm at -60, I will be on that dotted line. And now I need to go ahead and figure out where would this one end. Remember, to find your end point, take the phase shift and add the period to it. In this case, our phase shift was -60 plus our period was 180. So this function should end its cycle at 120 degrees. So on my graph, again, I was going by increments of 30. So if this is +30, +60, +90, here would be 120. And when sine does end, it's back at its 0 line. So when I'm at 120, I should be on the 0 line. Now to fill in the 3 points in between, notice that halfway between the beginning and end for sine, I should be at 0. So halfway in between, I should be at 0 here. And then in between the first and the middle, I should be up by however much I stretched. Typically it's up 1. In this case, since we stretched 4, we're going to actually go up 1, 2, 3, 4, where I'm halfway between. So I'd be all the way up here. Same thing between the middle and end point. I will just be below the line that much. So when I'm halfway between the middle and the end, I should be down below the line 4. So down 1, 2, 3, 4. From there, once I have those 5 points, I can draw in my curve. And again, this is all I'd be looking for. If you want, you can draw that, it keeps going and it keeps going with the same kind of pattern. But as long as you got one good cycle drawn in, that's all I would be looking for. I hope this helps with the work that you were doing today. If you're still lost, don't worry, I'll catch you back up on Monday.